Hello, I'm back. Welcome back, my dear friends, to your channel of learning mathematics. Remember last class what we did? Triangles. Something about triangles. Congruency of triangles we did last class, right? So last class we studied a little bit of triangles. We studied about congruency. Congruency means everything same, no? And then of course we also studied about what were congruent triangles? Triangles were said to be congruent if all the sides or corresponding sides are same, if all the corresponding angles are also same, right? And then we also learned about criteria for proving the congruency of triangles. So there we had proved, there we had learned that to prove that two triangles are congruent, all their sides have to be same and all their angles have to be same, right? Nah. Got you. No, we don't necessarily have to prove that all the sides and all the triangles have to be same for two triangles to be congruent. We had 5 criteria, you remember that, isn't it? So if we're able to prove the triangles using those 5, any one of the 5 criteria, we can easily go for saying that the triangles are congruent. And once we are able to prove that the triangles are congruent, then we can say that the other sides and the other angles are also equal. Remember how many were there? 5 were there. First one, side, angle, side, angle, side, angle, 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 side, 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 RHS. These were the 5 criteria. Remember that, isn't it? I hope you have your notes, everything. Write it down. I hope all of you have your notes and everything back, right? So pick up your notes, pen, paper. Let us begin. Alright, so I'm Sir Durba here. I welcome you back to your channel of learning mathematics. We are going to do now today exercise 7.1. Don't worry, we're not going to be doing all the questions. We're going to be doing maybe 4 to 5 questions. Alright, this question I've already written down the question, but I believe all of you have your textbook, so I'm not going to write the questions from the next question onwards. Okay, alright, so let's get to the point. In quadrilateral ABCD, quadrilateral means any figure which has 4 sides, no? So in quadrilateral ABCD, actually ACBD, that's why. ACBD, AC is equal to AD, AC is equal to AD. Chalo, AB bisects angle A, AB bisects angle A. This is angle A. Angle A means complete angle, this one. And it says that AB bisects angle A. Bisect means what? Bisect means this one. Middle. Equal pieces. Bisect means cutting into equal pieces. So when you talk of an angle, it will be into 2 equal parts. That means this line AB is cutting the angle into 2 equal parts, same angle. That means if this is 30, this is also going to be 30. So the word bisect is generally used that there. If it's bisecting a line, that means the line is also cut into 2 halves. That's what it means. Okay, na? Okay. Alright, so we have to prove that triangle ABC, this triangle is congruent to triangle ABD. Very simple. Chalo, let's prove. Proof. Quickly. Given. Let's try at least what is given. AC is equal to AD. Chalo. AB bisects angle A. That means angle CAB. Angle CAB will be equal to angle DAB. No, same angle. Angle DAB. In lines and angles, you must have already seen that angles and all we can name it in our own ways. I have named here CAB. If you don't like it, you can also name it as BAC. Should be in the middle, but that's it. Okay, the arms. Okay, so we have these properties. So let's go for proving that the 2 triangles are congruent. Another question is, what can you say about BC and BD? BC and BD, that we will talk later on. So in triangle quickly, A, B, C and triangle. Okay, how have they named in the question? ABD. In triangle ABD, what happens? AC is equal to AD given. Now, angle CAB is also equal to angle DAB. So this also can be said as given. How many criteria do we need? We need three conditions, at least three. So this side, this angle, this angle. See, AB. This is a common side for both the triangle, isn't it? Common, same, AB. So AB is also equal to AB. That is, we can just write common side. Common side. So what property shall be this? So by what property you see here? If you remember, side, angle in between the two sides. Side, angle. So the angle is between the two sides. We have the two sides, this and this angle lying in between the two sides. So what property was that? Side, angle, side, isn't it? Side, angle, side. Right? Angle included between the two sides. By side, angle, side, congruency. Okay, first one I'll just write. CONGRUENCY. CONGRUENCY. Criteria. Triangle ABC congruent to triangle ABD. Bas, proved. That's it. Simple. So whenever you go for proving the congruency of two triangles, just try to use any one of the, try to prove using any one of the three criteria. Bas, so you'll have to search for that only. Alright. Then the second part of the question was, what can you say about the side BC and BD? So see, the two triangles are already congruent, so BC and BD will be same, equal. BC will be equal to BD. Why? What did I say? In short, because they are what? Corresponding parts of congruent triangles. Because we have already proved that these two triangles are congruent. So the sides, even the angles are also going to be same now. Okay now? Alright, you can write it down. You can pause maybe and write it down. Okay. Let's move to the second question now. Chalo, pick up your textbook. Find out. Question. What is the question? Chalo. I'll not write the question. I'll just draw the figure. NCERT textbook. Okay, we have a quadrilateral. I'll just write what is given. In short, quadrilateral ABCD. AD is equal to AD is equal to BC. AD is equal to BC. That's why dash there. Huh? Angle DAB is equal to angle CBA. You have to recognize this. Angle DAB, that means this angle. Angle DAB, okay, is equal to angle CBD. CBA. Angle CBA. This angle. That means these two angles are equal. Okay, that's what it means. Of course, I'll complete the diagram. So to prove, number one, what are we supposed to prove? I'll go number wise. Triangle ABD is congruent to triangle BAC. Let me just write down. Second one, I have to prove that BD is equal to AC, and the third one, I have to prove that angle ABD is equal to angle BAC. Okay, these are the things that we have to prove in this question. So, how shall we prove? Okay, now look here. I'm going to cut out the triangle ABD and BAC. Okay, this one written down, rubbing. Angle ABD. I'll just cut by a scissor. So this is A, B, I'll just draw here. Okay, na? Angle ABD. So this is AB without changing anything, okay? ABD. And the other one is BAC. BAC. So it's something like BAC. BAC. What is given is AD. What am I doing, man? This is D-tone. ABD. AD and BC, they are same, okay? And what was DAB? DAB is equal to CBA. After cutting off the triangle. Okay? You can do like this. That way it helps. Okay? It really helps a lot. So that otherwise, sometimes just by looking at the figure, no, it becomes too messy. So we can just cut it out like this. Then it becomes very comfortable. Okay? So in triangle ABD and triangle BAC. Let's try to prove that they are congruent. That's what we have to prove. First one already given. One side AD is equal to BC, already given. One angle already same. Angle DAB is equal to angle CBA. This is also given. Angle DAB is equal to CBA. This is also given. Now you see, anything same in these two triangles? Any side same? Check properly. Any two sides same? Put it in the comment section below if you can find any two sides same here. Chalo, write it down in the comment section. Which one is it? Yes, AB. So if you can see here, AB, ABD and CBA. So AB becomes the common side here also. So AB is equal to AB, common. I'll just write in short, common side. So what do we have here? Side, angle. So here also I'll rub okay, I'll just write here because I need the triangle, no? Okay, so I just don't need this anymore now. So I'll just write here then because I need the triangle. So again, by side angle side criteria, TERIA, congruency criteria, actually you're supposed to write by congruency criteria. Triangle ABD is congruent to BAC. Okay, that's what we have to prove, isn't it? Triangle ABD is congruent to a triangle BAC. Okay. Second one, BD is equal to AC. We have to prove that BD is equal to AC. Already proved. How? BD is equal to AC. How did you prove that? How is that possible? BD equal to AC? Yeah. Congruent parts, corresponding parts of congruent triangle, CPCT. Very simple, because you already proved though these two triangles are congruent. So remaining all the triangles, all the sides and all the angles will be equal. Very easy. Third one, you have to prove that angle ABD is equal to angle BAC. Yeah, this one also see within the same triangle. Angle ABD is again equal to angle BAC. What? Here also corresponding parts of congruent triangles, CPCT. Angle ABD is equal to angle BAC. Congruent parts of congruent, corresponding parts of congruent triangles. So see, simple to na. You have to stick to the basics, but identify. I've already given you a method how you can just take out the triangle. Yeah, geometry is not difficult, okay. It's interesting actually. You don't have to remember formulas here. It's not messy like algebraic expressions and all. You just have to use common sense, which is not very common. Alright. Next one, number 3. Come on, let's do number 3. Write down. Get the question. I'm drawing the figure. The 90. This one means 90 degree. 90. A, this is O, joining point. B, C, D. Dash means these two sides are same. Pakka. Given AD and BC are equal perpendiculars. AD and BC are equal perpendiculars to a line. So it's already given in the figure also. You have to identify from the figure also. Okay, AD is equal to BC. To show CD bisects AB. To show this line CD, CD, that line that is coming on the way, what happened? It is bisecting AB. Bisecting a bisection, what did I say? Chalk, middle. Bisecting means this line CD, as it passes by, it is cutting the sides AB into two equal halves. That means I have to just prove that this side is equal to this side. If I can prove that this side is equal to this side, then aram se, because that means CD is bisecting AB. That's what I have to prove. That means I have to prove that if I can prove that OB is equal to OA, then maybe something may happen. Chalo? So for that, how shall we proceed? If I can again prove that these two triangles are congruent, let's try. In triangle OBC and triangle OAD. In triangle OBC and triangle OAD or AOD, BOC, whatever be it. Okay, let me just write like this. BOC, AOD. Anything same? Yes, already given. One side already same. AD is equal to BC. Given. Anything else same? Yes. This means 90. 90. Angle OAD is equal to angle OBC. 90 degree each. Acha. Anything else same again? Yeah, sir, nothing is same. What to do again? There is something more. See, this angle is equal to this angle. Vertically opposite angles. Chapter 6 we have already seen. If you haven't, then please go back and watch those chapter 6 videos. So these angles are opposite angles, vertically opposite angles. That is angle AOD is also equal to angle BOC. In short, vertically opposite angles. So by what criteria here? We have here angle, side. Because the side is not this one, so we cannot write angle. See, we had two criteria, angle, side, angle, and the other one was angle, side. Angle, side, angle was used when like we have something like this. Two angles involved, the side involved. Now, two angles and the side containing both the angles, then we use angle, side, angle. Or if it's two angles and the third side is just another side, then we use angle, side. So by angle, side criteria, by angle, side congruency criteria, again I forgot to write, but chalo, you write. Again by angle, side criteria, triangle BOC is congruent to triangle AOD. So what will happen is, now that means these two triangles are congruent. That means OB is equal to OA. See, already proved. And if you wish, we can also say that OC is also equal to OD, because these are all congruent parts of corresponding parts of congruent triangles. So CD bisects AB. Bas. Simple as that. You can see it is not very difficult. Most of you must have thought, yeah, I'm not going to do geometry. Chalo, number 4. I think you're still there, awake. Number 4. 4, 4, 4, 4, 4, 4, 4, 4. L and M are parallel lines. That means something is there. Intersected by another pair of parallel lines PQ. What happens when we get parallel lines? When we get parallel lines, then we get the conditions of alternate interior angles. We get the condition of corresponding angles. Remember? We have to prove that triangle ABC is congruent to triangle CDA. Already one side to common. Even before we started the proof, already one side common. Chalo, ek to mil gaya. Now look here. Remember this one? Two parallel lines. A line cutting. That line is known as transversal. This angle equal to this angle. Y. Alternate interior angles. This angle equal to this angle. Y. Alternate interior angles. Look here. Parallel line, line cutting. If we just extend time pass, then you see this angle equal to this angle. This angle also equal to this angle. We can look it like that also. Even PQ also. PQ again a transversal. LM, again a transversal. Both ways. This. Alternate interior angles. So you see what happens then in that case. That means in these two triangles, this angle equal to this angle equal to this angle, this side equal to this side, angle, side, angle, whatever we get. Forget it now. Question number 4. Given L parallel to M, P parallel to Q. Actually, it's not needed. One is needed, but anyway. To prove triangle ABC congruent to triangle ADC. Okay, I'm just going to rub this part. This is not needed. So, proof. We'll just go for the proof directly. In triangle ABC and triangle ADC. In triangle ABC and triangle ADC. Okay, some of you must be thinking, are you sending the question to CDA given? Why are you writing ADC? It's all the same actually. ADC or CDA or CAD. Okay, chalo. For your convenience, I'll just write what? CDA. CDA. Central Defense Academy. CDA. This one is okay, na? ABC. Okay. What happens? AC is already equal to AC. Common side. Common side. Angle. Let's talk of these two angles. This angle equal to this angle. So what is this angle? How can we name? We can name it as BAC. We can also name it as CAB. Whatever you choose. Angle BAC is equal to angle DCA. Angle DCA. And the other one is this angle is equal to this angle. That is angle DAC. Angle DAC is equal to angle BCA. Angle BCA. Now why is this? They are alternate. In short only I am writing interior angles. Why? Because the reason is like P is parallel to Q, L is parallel to M. And this should be enough. No need to write so many things in detail. That's one problem with our system. This is understood already, because these two lines are parallel, that's why they are alternate interior angles. So once the teacher gets the idea that okay, this guy knows what he's doing, I think that's enough. Okay, I think that's enough. That's what I feel. Because if you write this, that means you also understand how are you just saying that they are alternate interior angles, because they're parallel lines. Parallel lines, so whatever be transversal, these two angles are equal, or if it's like this, transversal, then these two angles are equal, these angles are equal. So no need to write so many things in detail, no need to write the whole story. Write what is enough. So now look here. These triangles, angle, 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 and the side is involved. So it's something like, what did I say? Angle, angle, side involved. So this will be what? By angle, side angle. Okay, this time I'll write congruency, what? Congruency criteria. What? Triangle ABC congruent to triangle CDA. हो गया ना? Satisfied? Okay. All right then. So that should be it. You want to do more? Alright, so I'm going to stop here, question number 1 to 4, because you might be already feeling sleepy. Okay, alright then, so find that. Yeah, the question that I was telling you was, what was that question? Is triangle a polygon? This was today's trivia question. Is triangle a polygon? Answer should be yes, triangle is a polygon. What shape is a triangle? If somebody asks you, then a triangle is a triangle. A triangle is a polygon. What is a polygon? A polygon is like a figure which is formed by joining points with straight lines. So actually, a triangle is the most simplest polygon, because other polygons will have 4 sides, 5 sides, pentagon, hexagon. So triangle is the simplest polygon, minimum sides like 3 sides. After that the 3, 4, 5, 6, 7 goes on. So yes, a triangle is a polygon. Alright then, thank you so much. I'll see you again in the next video with the other questions. Alright, so if you still haven't subscribed, please subscribe Cardona and give me a like. Okay, alright then, bye bye. I'll be back.